Welcome back. In this session, we'll try to discuss the digital signature, which is very important topic. What is a digital signature? So, handwritten signatures and stamped seals prove authorship of the content of a document. Digital signatures can provide the same functionality as handwritten signatures. So, unprotected digital documents are very easy for anyone to change. So, a digital signature can determine if someone edits a document after the users sign it. A digital signature is a mathematical method used to check the authenticity and integrity of a message, digital document, or a software. So, in many countries, digital signatures have the same legal importance as a manually signed document. So, electronic signatures are binding for contracts, negotiations, or any other document requiring a handwritten signature. And audit trail tracks the electronic documents history for regulatory and legal defense purpose. So a digital signature helps to establish authenticity, integrity, and non repudiation. Digital signatures have specific properties that enable entity authentication and data integrity, as shown in this diagram. So, this digital signature is used for signature is for your authentic, signature for your unalterable, signature is used not for the reusable, and signature that cannot be repudiated. So, digital signatures are an alternative to HMAC, the hashed message authentication code. So, we'll see the non repudiation. So, what is the non repudiation? To repudiate means to deny. Non repudiation is a way to ensure that the sender of a message or document cannot deny having sent the message or document, and that the recipient cannot deny having received the message or document. A digital signature ensures that the sender electronically signed the message or document. Since a digital signature is unique to the individual creating it, that person cannot later deny that he or she provided this signature. This is non repudiation. So, what is the process of creating a digital signature? So we'll see this, the how digital signature technology works, or how the processes of creating a digital signature. Asymmetric cryptography is the basis for digital signatures. A public key algorithm like RSA generates two keys. One is private key, another one is the public key. So these two keys are mathematically related to each other. And suppose Alice, you know, wants to send Bob an email that contains important information for the rollout of a new product, suppose. Alice wants to make sure that Bob knows that the message came from Alice only and that the message did not change after Alice sent it. So Alice creates the message digest and creates this message along with a digest of the message, and she then encrypts this digest with her private key. So that message plus the applying this goes through this hash function, so it generates a digest. That digest is done with the private key, and that is encrypted with this private key. Okay, so Alice bundles the message, the encrypted message digest, bundle this message and message digest with this private key, and her public key the Alice bundles this message, the encrypted message digest and her public key together to create the signed document, create the signed document like this. So one is the this bundle, this encrypted message digest plus the message and the public key as signed document, and Alice sent this signed document to Bob. Try to send this to Bob. So this is the message creation, that is processing of creating a digital signature on sender side. So what happens on receiver side now, on Bob's side? Okay, Bob receives the message, and the message is received by Bob and reads it. But how? So to make sure that that message came from Alice, he creates a message digest. He creates a message digest of the given message in this document, and he takes the encrypted message digest received from Alice and decrypt it using Alice public key. So Bob compares the message digest received from Alice with the one he generated. These two, current message digest and original message digest. If they match, Bob knows that he can trust that no one tampered with the message. So you can use this link. Okay, for more details, we are going to give you one link, the video which explains the process of creating digital signature in the document. So next we'll see here the details of or using these digital signatures, how and where they are going to be used. Like signing a hash instead of the whole document provides efficiency, compatibility, and integrity. Organizations may want to replace paper documents and ink signatures with a solution that assures the electronic document that meets all legal requirements. So these following two situations that provides the examples of digital signature. One is uh, your coding sign. So this code signing is used to verify the integrity of executable files which are downloaded from a vendor's website. And code signing also uses signed digital certificate to authenticate and verify the identity of the site. So that you can see in this figure. In this digital signature details, you find that the signer information, that is Adobe Systems Incorporated, and the counter signatures that gives the name of the signer, email address, and timestamp. So it gives the more details about the signer information by clicking on view certificate. Right? So now another one is digital certificate. This is another use of your digital signature. So in this digital certificate, which is used to verify identity of an organization or individual, to authenticate a vendor website and establish an encrypted connection to exchange the confidentiality. So here you can see this certificate information. This certificate is intended for the following purpose, and important the issuer is which is digital certificate is issued to Adobe system that incorporated. So where we observe that code signing, and who is issued this certificate to this Adobe system means the systematic class 3 extended validation code signing certificate authority, CA. And for this digital certificate, the validity period is also given. So if we click on this issuer statement, it gives more information. So this certificate details displays the purpose of this certificate and who it was issued to and who it was issued by, and it also displays the amount of time, the valid period of time. So now let us see comparing the digital signature algorithms. Comparing the digital signature algorithms. So the three common digital signature algorithms are: one is digital signature algorithm, DSA. Another one is reversed Shamir Adelman or RSA algorithm, which is the another one is elliptic curve digital signature algorithm. All three digital signature algorithms generates and verify digital signatures. These algorithms depend upon asymmetrical encryption and public key techniques. Digital signatures requires two operations. One is key generation, another one is key verification. So both operations requires key encryption and decryption. So that is private key and public key. So the DSA, the digital signature algorithm, uses the large number of factorization mathematical operation. So governments use this DSA for signing to create digital signatures. So this DSA does not extend beyond this signature to the message itself. RSA is the most common public key encryption algorithm in use today. So this RSA is named after these individuals who created in 1974. One is Rand Revest, another one is Adi Shamir, and another one is Leonard Adelman. So this RSA is the most common public key encrypt in today's. So RSA depends on asymmetrical encryption. One key is used for encryption purpose, another key is used for your decryption purpose. So two different keys are used in this RSA algorithm. So RSA generates two keys, even all other algorithms also. RSA covers signing and also encrypts the content of the message. DSA is faster than the RSA algorithm as signing services for a digital document. RSA is best suited for applications requiring the signing and verification of electronic documents and message encryption. Like most areas of cryptography, the RSA algorithm is based on two mathematical principles. One is modulus operation, another one is prime number factorization. So you can click here to learn more about click on this particular link so that you can learn more about the RSA that use both modulus and prime number factorization. So another separate video is there for this. I'm not going in details of the RSA, how these primary key, the two keys are going to be generated. Please use this link to get more information. Next, the ECDSA digital signature algorithm is the newest digital signature algorithm that is gradually replacing this the RSA algorithm. So the advantage of this new algorithm is that it can use much smaller key sizes for the same security and requires less computation than the RSA algorithms. So by getting this concept, you can complete your the lab work for this digital signature. So in this lab work, you will complete the objectives that understand the concept behind digital signature and demonstrate the use of digital signature and demonstrate the verification of digital signature. So, with this, I'd like to stop this session. In the next session, we'll try to discuss the digital certificate.